Hello students. So welcome to today's video. In this video, which is second lecture in my factorization series, we would see how should we factorize a algebraic polynomial if it is expressed as four terms, right? So if it is expressed like something like x squared plus 3x minus 4x plus 12. So when there are four terms given to us, how should we factorize that? We will see this in this video. Then we will move on to you know the sum and product type. So what is sum and product type? So say if we have a quadratic trinomial such that the coefficients of the middle term and the coefficient of the term without any variable are arranged in such a way that the middle term can be splitted as sum and product. What is that? We'll look into it once we go deep into that practice problem. And finally, when even this does not work, how do we use our last technique, that is the pure middle term splitting, that we would see. So says if an expression is given as 15x squared plus x minus 6, then how should we be factorizing that? We would see that as well towards the end. But before we go into our today's topics, right, let's do a quick 5 minutes recap of what we covered in our lecture one of quadratic of factorization, so that it would help you connect the dots. And obviously, if you have not gone through the first video of the series, I would recommend you to go to the first video of the series as well, and then obviously come into that so that you will be able to connect all the dots. Okay. Nevertheless, here we would still do a quick recap of what we saw in the first video. So say if we are to factorize 2x cubed plus 8x, 2x squared plus 8x cubed, 2x squared plus 8x cubed. If I want to factorize this thing, so this obviously falls in my common factor elimination technique, right? So this is always step one in factorization. If there is a common term across all the terms in the expression, to factorize it, first look for what is the common term across all the terms, and if there is anything, then obviously eliminate it. Now between these two terms, obviously the highest common factor is 2x squared, right? So if I take 2x squared as the common factor, then obviously the first term becomes 2x squared by 2x squared, that is nothing but 1, right? Plus 8x cubed by 2x squared is nothing but 4x. Okay, so this would be my answer. So the fully factorized expression for 2x cubed, sorry, 2x squared plus 8x cubed would be 2x squared into 1 plus 4x. Now let's do a quick check if it is fully factorized or not, right? So here my expression was expressed in terms of summation or summation of two terms, and here in my final answer I have expressed it as something into something, which means these are factors of this, so which means my point number one is satisfied. Okay, now point number two, what is the highest power of x in this expression? This is 1, so which is good, and the only other term is 2x squared. So x squared also can be written as 2x into x. If you want to write, this is also fine. But if you write 2x squared also, that is fine, because there is no plus or minus here again, right? So that's why this is the fully factorized form of 2x squared minus 8, sorry, your plus 8x cubed. Okay, so if it is 2x squared plus 8x cubed, so this would be the answer. Okay, so this is nothing but our common factor elimination, and I repeated that many times when we are solving practice problems on factorization, first and foremost thing that we should do is try to eliminate the highest common factor. Okay, so that's where we will end our recap of the first type, that is common factor elimination. Now let us go and see the other things which we saw in the first video, right? The second thing was we saw the use of three identities. So if my expression is given in terms of a square minus b square, then obviously it can be factored as a plus b into a minus b, right? So we, by using that identity, we can solve this problem. X squared minus 81. So if you see, this is nothing but square of x minus square of 9, right? So it can be easily expressed as a square minus b square. And if it can be expressed as a square minus b square, obviously I can factorize it as a plus b into a minus b, that is x plus 9 into x minus 9 in this case. And I would recommend you to get into this habit that you should always write because of that identity, because we know we know a squared minus b squared equals to a plus b into a minus b. Write this identity again. So sometimes students ask me that, sir, is it needed to write the reason? And let me tell you the very important reason why I recommend this is, so today I see many developers in IT industry, they write code, but they always find it very troublesome or tedious to write the comments for what that code is, right? And I personally believe that if as a students we get into the practice of writing these reasons, obviously it would get into our gene, our blood, and when we grow up in our life, we would have that good practice. So as a teacher, I would recommend that you should get into the habit of writing the reason as well. Okay. Now let's go to the next one in the identity series. Okay. So next problem which I indicated, x squared plus 4x plus 4. So if I want to factorize this one, x squared plus 4x plus 4. So if you see here, I can rewrite it like this, right? And it is square of x, right, plus square of 2, and the middle term can be easily written as 2 into the first term a into the second term b, right? So if you see, I have just written 4x as 2 into x into 2. So 2 into 2, 4 into x, 4x. So this is fine. Square of x, this is fine. Square of 2, this is fine. So if my expression can be rewritten as a square plus 2ab plus b square, obviously I can use this second identity, and that's why I can write it's nothing but x plus 2 whole square, and obviously write the reason that because a square plus 2ab plus b square is nothing but a plus b whole square, and this is the fully factorized form of this. If you want, you can also write x plus 2 into x plus 2, which is even better. But if you stop here also, this is perfectly fine. Okay. Now let's go to the next one in our identity series. So that is x squared minus 20x plus 100. So if you see, just a small change, the middle term is expressed in terms of minus 2ab. So the first term is square of x minus 2 into x into 10x plus 10 square, right? So this can be written as x minus 10 whole square, and the reason is this identity. A square minus 2ab plus b square is a minus b whole square. And as I said you, if you leave it right here, this is also correct. Or if you want, you can write x minus 10 into x minus 10. This is also correct. Okay. Now, so this is what we have covered in our first video. Okay. But there could be situations where rather than getting three terms in the algebraic expression to factorize it, sometimes we may get four terms. Okay. Sometimes we may get four terms, and If there is a common term across all of them, I would recommend obviously you should first eliminate the common factor. But let's take this example. X squared plus 3x minus 4x minus 12. Okay, so if I want to take x as the common factor, that would be common factor across this, and this. But obviously the term 12, I cannot take x as a common factor from this. Even if I take, the remainder here would be 12 by x. So my x will go to denominator. So obviously my expression would be further complicated. So it is not the right direction in which I should be moving, right? So that is why I would do a different, trick here. I will apply a different technique here. So if you see, though there is no common factor across the terms, I can still logically group this as, these two as one term and these two as one term. So we can use this, right? So this is nothing but x squared plus 3x, right? Minus, if I take 4x plus 12. So nothing is changed, right? So I have just retained the same equation. Okay. So I have just grouped these two terms together and I have grouped the other two terms together. That is all I have done. I have not made any other change. So obviously I can give the equal to sign here. Okay. Now if we see between these two terms, I can take x as the common factor. So what would be the remainder? The remainder would be, here it is. For the first term, x squared by x equals to x, plus sign, I retain the plus sign, 3x by x is nothing but 3. So x plus 3, right? So there's a minus sign between both of these terms. So I'll retain the minus sign and let us see how does this part changes. So between these two terms, I can take 4 as common or common factor. So what would be the remainder? 4x by 4 is nothing but obviously x, and 12 by 4 is nothing but 3. Now interestingly, if you think, this is one term, this is another term, and if you see this expression or this term itself is common across these terms, right? So which means I can take x plus 3 common between this as one term and this as the other term. So if I take x plus 3 as a common factor, so which means I need to divide x plus 3 to both of these terms. So x into x plus 3 by x plus 3 would be nothing but x minus, I will retain the minus sign, 4 into x plus 3 by x plus 3 is nothing but 4. So if you see, now my expression is fully factorized. It was expressed in terms of addition and subtraction of 4 terms, but I have expressed is as product of two expressions or two terms where the highest degree of x is 1 or variable is 1. So which obviously means this is the fully factorized form of this, 4 terms expression, right? Okay, so if you want to type down, I'll just give you a couple of moments and then we'll go to the next practice problem. You can type it down. Okay, and in the meanwhile, let me write down the next question in the middle terms, in the 4 terms. So we'll go into that. So the next question would be AB plus 6 plus 2B plus 3a. Okay, so if you have noted this down, now let us go ahead and solve the second practice problem of this factorization series. So my question is AB plus 6 plus 2B plus 3a. Okay, so again, here also if you see, I have got nothing common across all the terms. If I try to take a as common, obviously it will be difficult for me to take it as common factor between 6 and 2, right? I cannot take a also I cannot take 2 also. If I take 2, I can take between these two terms, but I cannot take across the last first and last term. Similarly, if I want to take 3 as the common factor, I can take in this from the fourth term and the second term, but I cannot take from the other terms. So which means there is no common factor across all the terms in this expression also. So let's just follow what we saw few minutes back. Let's group them in pairs. Okay. So if I group these two as pairs, now between AB and 6, what would be the common factor? If you see in reality between these two, there is no common factor. Similarly, between your 2B and 3A, there is no common factor, right? But if you see, let me just change it slightly. So can I write this expression as AB plus 3A plus 6 plus 2B, right? Why? Why? Because addition is your associative, right? So you can always do that, right? So that is perfectly fine. I can use the property of addition, and that's why I can shuffle this expression like this. Okay. And now if I take these two, as one pair and these two as another pair, let's see what would happen between these two. What could be the common factor? The common factor obviously would be A. If I take A as the common factor, then it would be AB by A is nothing but B, then plus sign 3A by A is nothing but 3. Similarly, in the second pair, if I take 2 as common, right? So it will be 3 plus B. Okay. So obviously I can write A into B plus 3 plus 2 into 3 plus B is nothing but B plus 3. Again, because your addition is your commutative. A plus B equals to B plus A. You can always change that. That's perfectly fine. Okay. So now if you see between this term and this term, again, this B plus 3 is a common factor. So if I take B plus 3 as the common factor, it comes out to be B plus 3 into here, it would be A, then the plus sign, and 2 into b plus 3 by b plus 3 is nothing but 2. So your answer is nothing but this. So if you see, it was expressed as addition and subtraction of multiple terms, and I finally expressed it as product of multiple expressions or multiple terms where highest power of variables are 1. So obviously that means this is fully factorized. So the only trick that we used here was we just reshuffled the expression so that there could be some logical common factor. So this could be one small trick, that the equation or the way the expression can be would be given to you, you would not see any common direct factor even between pairs, but if you shuffle them, then you can easily find. Okay. And obviously, does it mean that whenever you shuffle you will get it? The answer is no. But in factorizations, they will form the terms, or they will form the expressions in such a way that if you shuffle them, you can get it, right? So that's how the problems would be in the exam. Let's see a couple of more problems. So x squared plus 5x plus 4x plus 20. Again, there are four terms and there are no common factor across all the terms. But if I take these two as a pair and these two as a pair, it will be pretty easy. So if I take x as the common factor here, then the remainder will be x squared by x is x, 5x by x is 5, plus here also if I take 4 as common or common factor, then 4x by 4 is x, 20 by 4 is nothing but 5. So x into x plus 5 plus 4 into x plus 5, that is nothing but x plus 5 goes as a common factor, and the remainder is here, it will be x. We retain the positive sign, and 4 into x plus 5 by x plus 5 is nothing but 4. So that's why the answer would be x plus 5 into x plus 4. So don't think that every time you have to shuffle. So sometimes it will be pretty easy, pretty neat in front of you, and sometimes you may need to shuffle them based on the problem given. Okay, so let us go to the next practice problem. Okay, so this is mn plus 3p, mn plus 3p, 3p plus np plus 3m plus np plus 3m. Okay, so here also if you see, it makes more sense to push this term to this side and this term to this side. So that is nothing but we can write mn plus np plus 3m plus 3p. So you may ask that, how would you know where to shuffle? And my static answer to that would be by practice. So in mathematics, that's why they say mathematics is also like a bit of methodology. So we know how to reach to, we know the end goal where you want to reach, but obviously what is the exact path? It's not always defined. You need to find it out. It's like a treasure hunt, right? So if I reshuffle it like this, then if you see, I'll take these two as first pair, these two as second pair, right? Between these two terms, the common factor is n. So the remainder would be m plus n, right? And between the third and fourth term, if I take 3 as the common factor, I'll get 3m by 3 is nothing but m, 3p by 3 is nothing but p. Oh, okay. So this would also not work here. So which means we have to change something here. So let's see. Okay. So what can we change? So it didn't work this way, it didn't work this way also. So which means obviously you cannot further factorize it. So that is what I was trying to indicate you, that sometimes you may end up getting problems which may not completely be factorized, but that's fine. If it cannot be factorized, don't force to factorize it forcibly. Leave it the way it is. So this could be the maximum thing that you can do, and leave it right here. Okay, so that's cool. So I just wanted you to understand that every time the factorization may not be possible. Okay, fine. So let's move ahead. Okay, so let's move to the next one, that is sum and product type. Okay, so when we say this sum and product type, this one is pretty interesting. So if you see here, okay, so we have taken up this term, right? So let us understand for a moment this expansion, so that the factorization would be very easy for you. Okay, so if you see, let us multiply these two terms, x plus a into x plus b. Okay, so let us expand it. So what it would be, it's nothing but x into x plus b, then plus sign, next term is a into x plus b. I'm just expanding this expression. Okay, so which would mean x into x is nothing but x squared, then plus sign, x into b is bx, right? Then plus sign, a into x is ax, and then it's a into b is ab. Okay, so if I arrange it slightly, I can rewrite it like x squared plus a plus b. So if I take x as the common factor between these two terms, so this will be x into b plus a, and then it's ab. Okay, let me do a bit of rearrangement here. I can rewrite this that x squared plus a plus b into x plus ab. Now my initial factor or initial expression was given like this, and I arrived at this thing. And we know this is what we did in expansion. Okay, expansion or we have done the we have found out the product of x plus a into x plus b. So we have found out the product of x plus a into x plus b. So obviously we know that the reverse operation of this is nothing but your factorization, right? So which means just like we use the identity that if my term is in the form of a square minus b square, I can factorize it as a plus b into a minus b. You can use this also as another identity such that if your expression is given like this, x squared, coefficient of x is 1, okay, or coefficient of the variables will be 1, and there is some coefficient of the middle term which is expressed as the first degree of the same equation. Okay, so if it is x squared, then the formula may not work. Okay, so that's why if the first term is square of the variable, second term or the middle term, okay, is sum. If you see, it's the sum of the coefficients of the first of the terms, right? So x squared plus a plus bx, so the terms are a and b. Okay, if it is addition of two things and the third term is the product of the same two things. Okay, so that's why we say if you are getting, you know, a polynomial or a trinomial of the second degree, or a quadratic trinomial such that coefficient of the middle term can be expressed as sum of two, numbers, and the last term or the term without the variable can be expressed as the product of the same two things, then we can easily factorize that as x plus a into x plus b. In some books, they would write it like this: x squared plus alpha plus beta into x plus alpha beta. That's fine. Whether you use a plus b or alpha beta, that's fine. But at the end of the day, it should be sum and product type. I repeat, if you have a trinomial, a quadratic trinomial, which means a three-term, expression where highest degree of the variable is 2, right? Such that it can be expressed as x squared plus sum of two things into x plus product of the same two coefficients, then we can write, or then we can factorize it as x plus a into x plus b. Okay, so let us see a couple of practice problems on this for us to understand. So the first one would be, so our identity or our new identity for sum and product type is, if it is expressed as x squared plus a plus b x plus ab, then we can factorize it as x plus a into x plus b. So let's see how should we use it. So suppose the problem is given as x squared plus 5x plus 6. Okay, now we need to find out the factors of 6 in such a way that this last term 6 should be so say a and b. So let us find out what are the factors of 6, right? So it could be 1 into 6, it could be expressed as 2 into 3, it could be expressed as 3 into 2, it could be expressed as 6 into 1. That's it. So which means the unique factors are 1 into 6 and 2 into 3. Now, if you see here, okay, the middle term 5x can be written as 2 plus 3x, and the last term can be written as 2 into 3, and the first term is written as x squared. Okay, so if the middle term is summation of, your two coefficients, and the term without any variable is the product of same two terms, then we can directly factorize this as your x plus a is nothing but 2 into x plus the other term is 3. This is the answer, and you can write, reason as this identity. If x squared plus a plus bx plus ab, then it could be factorized it as x plus a into x plus b. And if you are finding this is difficult, don't lose your heart. We have a crude simple way of handling that, which we would see towards the end. Okay, so don't be or don't lose your heart for that. Okay, so let's see some practice problems in this series so that it will be very easy. You may just write it down and then we will go into the next practice problem. Okay, so while you write it down, let me let me write down my next practice question on the board. That is nothing but that is nothing but okay, yeah. So x square minus 2x minus 8. Okay, so next problem that we would solve in this series is x squared minus 2x minus 8. X squared minus 2x minus 8. Okay, yeah. So let's see here. Okay, so now another interesting thing, if you see, the last term is product of two things, right? So if it is a into b, okay, so plus into positive is always a positive, and negative into negative is always a positive, right? So if a term is negative, then obviously either of the terms must be negative, because multiplication of two positive terms is also positive, and multiplication of two negative terms is also positive. So if you see here, if my final term is minus, okay, if my final term is minus, then obviously one of the two terms that I need to split, it must be negative. So that's an indication that you should understand here. Okay, so let us see what are the factors of 4 I can express it as. Okay, so 8 can be expressed as 4 into 2. Okay, and if I express the middle term 2 as nothing but 4 minus 2, 4 minus 2 into x, okay, and the last term is nothing but plus 4 into minus 2, okay, the first term continues to be x squared. So if you see, I again express this expression as x squared plus summation of two things, and obviously we know a minus b is nothing but a plus minus b. So as we are already in grade 9, so don't say this is 4 minus 2, so it's not summation, it's minus. Okay, so 4 minus 2 is nothing but this is actually your 4 plus minus 2, right? So is x squared plus a plus b into x into the same two things, a minus b. So what we should notice here is, if your this term is negative, then obviously remember at least one of the terms must be negative. Okay, at least one of the terms must be negative. So you should understand that when we are doing the factors of 8, it could be 1 into 8, it could be 2 into 4, it could be 2 into 2 into 2. So which one to take, right? So you should split it accordingly. Okay, so if I'm expressing it like this, now I can obviously write this is nothing but x plus 4 into x. What is the value of b? That is minus 2. So x minus 2. So this is the answer. X plus 4 into x minus 2. That becomes your answer. Right? So pretty easy. Okay. So you can just quickly go through it, and then I'll write the next practice problem on the board. Okay. So the next one is x squared minus 2x minus 15. Okay, so again, if the last term or the product term is minus, obviously at least one of the terms, at least one of the terms must be minus. So 2 can be expressed as, and it must be factors of 15. So if I take 3 into 5, so the difference between these two is 2. So 2 can be written as 5 minus 3 into x. Okay, and or if you want to write it properly, 5 plus minus 3 into x plus 5 into minus 3, and the first term is x squared. So the same thing, x squared into x squared plus a plus b into x plus a into b. So that is nothing but x plus a is 5 into x plus b is minus 3. So plus of minus is nothing but minus. So it is x plus 5 into x minus 3, which is your answer. Okay, sum and product type. Quickly type it down and then I'll write down the next question. Okay. Okay. Now let's go to the next one. X squared plus 5x, x squared plus 5x minus 24. Minus 24. So obviously again the last term is negative, so obviously one of the terms must be minus. So if this is very simple, that which factors of 24 you can express as 5. So if you take 3 into 8, so 8 minus 3 is nothing but 5. So this is where the problem is finished. So 5 can be written as 8 plus minus 3, this much into x minus 24 can be written as plus 8 into minus 3. Okay, and the first term continues to be x squared. Problem solved. So x squared plus a plus bx. Okay, yeah, so here it is given as minus 24, right? So this part you have to make it as plus. Okay, so make it as plus. So we'll just make it like this, right? So no, so I'm sorry, this is minus 24. Okay, so then we can solve it as x plus 8 into x minus 3. So that is the answer, right? So let's keep moving. Let's keep moving to the next problem. Okay, so x squared minus 16x plus 39. X squared minus 16x, x squared minus 16x plus 39. So if you notice here, now I need to find out factors of 39, and my last term is positive but my middle term is negative. So which means both of them, the way I split my middle term, it should be minus something and again minus something, so that if I have two terms as negative, so obviously the last term will be minus of something into minus of something, right? So it will be plus. So 16 can be written as minus 16 can be written as nothing but your minus 13, right? Minus 3, minus 13 minus 3 x. So I can write x squared plus minus 13 minus 3x, right? And the last 39, I can write it as minus 13 into minus 3. So problem solved. X squared plus a, okay, so I can write it minus 13 plus minus 3, right? And then x. So this will be x squared plus a plus b, x into the same things, a into b. So I can write the answer is x plus minus 13. That is that one x minus 13 into x plus minus 3. So x plus minus 3 is nothing but x minus 3. So this is the answer x plus x minus 13 into x minus 3. Okay, so this is where you should get an indication that if the last term is positive but the middle term is negative, then obviously both the terms would be negative and negative only, because summation of two negatives would continue to be negative, but the product of those two negatives would be positive. Okay, so that is how we should be thinking while we are thinking for this sum and product type. Okay, now let us quickly go and see that the last type of factorization. Okay, so let's move into that. So sometimes what happens, right? Your sum and product type, or expressing the middle term and the last coefficient as sum and product type is not always possible. So if that is not possible and a quadratic equation or quadratic expression is given to you for factorization, then we use this last term, and using this you can almost factorize everything. Yeah, there could be expressions which cannot be factorized, so obviously you cannot forcibly factorize it, but most of the equations can be, or most of the quadratic equations at least can be factorized using this technique which we are going to learn now. Okay, so say let's take, this is what is given in the question: 15x squared plus x, right, minus 6. 15x squared plus x minus 6. Okay, so if you see here, I cannot really use your sum and product type in this question. Okay, so if I cannot use sum and product type, what we tend to do is, okay, so say the expression is of the form ax squared plus bx plus c. Okay, so in that scenario we split the middle term or that this bx term in such a way, so your bx would be splitted into coefficient of two things. So suppose it is splitted as coefficient of m plus n into x, and it is splitted into two coefficients of m and n, such that your m plus n should be equals to b, and your mn equals to c into a. So c is the coefficient of the term where you don't have a variable. So mn equal to that coefficient into the coefficient of your x squared. So mn should be equals to ac. Now if you see, if you have got mn and if you have got m plus n and mn, so can I say that m minus n whole square is nothing but m plus n whole square minus 4mn, right? Because we know a minus b whole square is nothing but a plus b whole square minus 4ab. So obviously I can say m minus n would be the square root of this, right? So this is the technique. So we express the expression in terms of ax squared plus bx plus c. Okay, then we write down what is the value of a equal to how much, b equal to how much, c equal to how much. Okay, then the next thing is we split the middle term bx in such a way that m plus n will be equals to b, that is the coefficient of the middle term, and mn will be equals to ac, that is coefficient of x square and coefficient of the term where you don't have a variable. Okay, now obviously we find m minus n, and now if you know m plus n, if you know m minus n, obviously you can find out m equals to how much and n equals to how much. Once you have found out m equals to how much and n equals to how much, then you can put it back in the original equation and rewrite, and you can solve it. So let's see practically how should we solve it. Okay, So if it is given as 15x squared plus ax plus b, so I can write it that, okay, so if this expression is rewritten in the form of ax squared plus bx plus c, then what is the value of a? A equals to how much? 15. B equals to how much? Coefficient of x is 1, and c equals to how much? Minus 6. Right? Right? Okay. So then let the middle term let the middle term be splitted into m plus n into x such that your mn equals to how much? M plus n equals to b. So here your m plus n is how much? M plus n equals to b is 1. Okay, and your mn is nothing but, we know, AC. So if mn equals to AC, so your mn here is nothing but a is 15, c is minus 6. So 15 into minus 6, that is nothing but minus 90. Okay, so obviously 15 into minus 6 is minus 90. Now you know m plus n, you have found out mn. So let us quickly find out what is the value of m minus n, right? So m minus n will be how much? M plus n whole square, that is nothing but your m plus n here is 1. So square of 1 square. Okay, so is a plus b whole square minus 4 into ab, that is minus 4 into minus 90. Okay, root over. Okay, so that is nothing but square of 1 is nothing but 1, minus of minus is nothing but plus, 4 into 90 is nothing but 360, root over. So root over of 361. So root over of 361. So how much is the root over of 361? Let us quickly find out. So root over of 361. Just a minute. So this is, somehow my calculator is not working. Just give me a moment. I'll just quickly find it out here. Root over of 361. Okay, why this calculator is coming so slow? Just give me a moment. Okay. Okay, so I think it's taking a bit of time. So as it's a little difficult to find the square of this one, root of this one, we'll just go into a different problem and we'll see. But obviously the technique remains the same. So from here you find out the value of m minus n, and then obviously you can get the value of both, your m plus n and m minus n, and that's how it can be solved. So let us choose a little simpler one so that we'll not have this calculation issue. Okay, so let's go into this practice problem. So this is 2x squared plus 3x plus 3x minus 5. So here also, if you see, your a equals to 2, b equals to 3, and c is equals to minus 5, right? So obviously your we want to split the middle term into m plus n. So m plus n will be nothing but equals to b. So that is nothing but m plus n equals to 3 and mn equals to AC. So that is nothing but your mn equals to A is 2 here and C is minus 5. So 2 into minus 5, that is nothing but minus 10. Okay, so let's find out the value of m minus n, that is nothing but m plus n whole square, that is 3 square minus a plus b whole square minus 4ab. So ab is nothing but mn here, that is minus 10. Okay, root over. So 3 square is 9, minus into minus becomes plus, 3 plus 40, right? So that is nothing but root over of 49, that is nothing but 7. Okay, okay. So here your m minus n comes out to be 7. Now you know that m plus n is 3. So say this is equation 1, and this one your m minus n equals to 7. Say this is your equation 2. Okay, so you have got two equations and two variables. So solving the equations simultaneously, you can get the values of n, m, and n. How? Let's see here. Okay, so here your m plus n equals to 3 and m minus n has come out to be equals to 7. Okay, so if we add both of these, if we add both the equations, right? So adding equation 1 with equation 2, if we add both the equations, then what would it be? The left sides will get added and the right sides will also get added. So when left sides are getting added, the n will get eliminated, plus n minus n is 0. So m plus m is nothing but 2m. So that is nothing but 3 plus 7, that is 10. Or m equals to 10 by 2, that is nothing but 5. Similarly, to find out the other variable, just subtract both the equations. So bring 1 minus 2. So again, m plus n equals to 3, m minus n equals to 7. If we do a subtraction, the sign of this one will be negative, sign of this one will be positive. Okay, so obviously your plus m minus m, these two will get cancelled. So your 2n will be 3 minus 7, that is minus 4, or n is nothing but minus 2. So you found n equals to minus 2, m equals to 5. Now if we put the values of m and n in this equation, okay, or in this expression, then we can rewrite this expression as 2x squared plus, so 5 minus 2, that is m plus n, 5 plus minus 2 x. Okay, or you can directly write like this, that rather than 3x you can write 5x minus 2x minus the last term was how much, that is 5, right? So or 15. So x squared plus 3x minus 5. Yeah, so minus 5. So here, now we have come back to your first style, that we have got 4 terms and there's nothing common across them. So again, arrange them in pairs. So if you see, if I bring this 2x to this side and take 5x to this side, it becomes more meaningful. So I can rewrite this as 2x squared minus 2 plus 5x minus 5. Okay, now what would be the common factor? So the common factor now would be, if I take 2 between the first two terms, it would be, sorry, your 2x. So if I take your 2x as common, then it would be your x minus 2, right? And between these two terms, if I take, oh sorry, if it's 2x is common, then it will be 1. And between these two terms, if I take 5 as common, it would be x minus 1. Okay. Now, if I take this x minus 1 as common, then it will be x minus 1 into 2x plus 5. Answer. So if you see here, even in this problem, we have a bit of that, flavor of the first problem type that we solved, the four terms type, right? So if we, so don't think that when you are, working it in one style, you will not encounter the other type at all. Okay, so that will always be a, combination or mix and match of these things. Okay, so let us solve one more problem on Mutum splitting, and then we will stop our today's discussion there. Okay, so let's go and solve at least one more problem on Mutum splitting. Okay, so say, yeah, so let's go ahead and solve this one. 9x squared plus 3x minus 12. 9x squared. Okay, let's do one thing. Let us choose a different one, and there's a reason behind that. Just give me a moment, okay? So we had solved the other problems, right? Your x squared plus 4x plus 4. We have solved it using the identity a squared plus 2ab plus b squared, and we have solved it. Now let us see, can I split it using the middle term splitting or not? Okay, so here my coefficient of your x is nothing but 1. So a equals to 1, coefficient of x squared is 1, b is nothing but 4, and c is nothing but again 4. Okay, so what is the value of my m plus n? M plus n equals to b. So m plus n is nothing but 4, and mn equals to ac. Remember, many times students make a mistake here. They continue mn equals to c. Remember, it's ac, it's not only c. So mn is nothing but c is 4, a is 1. So 4 into 1, 4 into 1, that is nothing but 4. Okay, so what would be the value of m minus n? That is nothing but m plus n whole square, that is 4 square minus 4ab. A is 1 and b is nothing but what? Your 4, right? So 4ab, so 4 into 4. Okay, so if we take the root over of this, right? So here if you see, this term is coming as 0. Okay, so this term is coming as 0. So which means your m minus n equals to 0. If m minus n equals to 0, so can I say m equals to n? Okay, now if m minus n equals to 0 and m equals to n, I need not again, solve it through those simultaneous equations. I can just put this thing in any of the equations and find it out. So I know m plus n equals to 4 and m equals to n. So which means 2m equals to 4 or m equals to 2. Finished. If m equals to 2, then n is also equals to 2, because we have found out that the values of m and n are same. Now, just rewrite this expression using the middle term splitting. So I can rewrite it as x squared plus m plus n. M is 2, n is 2. So 2m plus, sorry, x squared plus 2x plus 4. Okay, now let us take anything common and across them. Okay, so if I try to take common here between your x squared, 2x and all, right? So if you see here, if we again try to take common here, we would fumble. We would not be able to properly solve it, because between these two terms, if I take your x as common, what I get? I'll get x plus 2, right? X plus 2, okay, into plus between these two terms, what will be common? The common term would be 2. Then the remainder would be again 2x by 2 is nothing but x, and 4 by 2 is nothing but again 2. Right? Now between these two terms, what is common? X plus 2. So if I take x plus 2 common, x plus 2 common, it would be here x into x plus 2 by x plus 2 is x, positive sign. 2 into x plus 2 by x plus 2 is nothing but 2. So again, if you see, we are getting x plus 2 into x plus 2, it is nothing but x plus 2 whole square. So that's why we say that by using this last technique, we can solve almost all the quadratic equations for the factorization. Yes, that will be few which cannot be solved, but mostly it will be solved. So that's why even in case of the sum and product type, if you are not able to mentally calculate that, how you can express it as sum and product type. Okay, so don't worry, just use this last thing, that is ax square plus bx plus c, and then use your m plus n equals to b and mn equals to ac. Use it, find out the value of m plus n and m minus n. From m plus n and m minus n, you can find out the individual values of m and n, and obviously again put it back in the expression value of m plus n, rewrite the main expression, and then by grouping of pairs you can easily solve it. Okay, so that is how you can solve the problems in your factorization. So with this we come to end of the theory and the your practice problems of factorization. We will have one more class on factorization, but there we would just have a jumbled up set of problems. I would not say initially that which type does it belong to, because obviously in your exam also they would not say which type does it belong to. So you need to look into the problem, think which type does it belong to, and solve. So we would have one curated, or you can say a combined set of problems practice for one video. So that's all for this video. Catch up in the next video. Thank you everyone. Have a good time.